This video is a tutorial on how we write the names and or formulas of all of the different types of compounds that we have learned. So we really learned how to write formulas and names for 4 types of compounds: binary ionic, ternary ionic, covalent, and then acids. I've left up the flow diagrams that we had previously used for writing the names and writing the formulas of things. So with the writing the name, this was the flow diagram we used to figure out what was going on. I'm going to add one thing here at the bottom because at this point we hadn't addressed acids yet. So first we'll look for number of elements, and then if it's a metal with a non-metal, which you'll find acids are, you name the metal, you name the non-metal with IDE or the polyion. Right? And then with this, we'll say if, when you're writing the name, you have hydrogen, anything, it's an acid. Right? And you use the table. And that's just a reminder as you go through. With the formula writing, right, we ID the components. Well, the second thing that it could be is if acid, use table to get old name. And then once you get the old name, you just follow what you see above. So we'll slide that back, because what I have right here are 8 different formulas, and anytime we're looking at the formula, our goal is going to be to write the name of that compound. So, as we take a look, I look at K2S, and K2S has 2 elements. So I need to check, is it a metal with a non-metal or 2 non-metals? To save moving the periodic table back and forth all the time, make sure you have a periodic table out, and you would see that K lies to the left of the staircase in group 1, S lies to the right in group 16. That means we've got a metal plus a non-metal. Anytime we have a metal plus a non-metal, we name the metal, we name the non-metal with IDE, and then we check if it's a transition. So if I name my metal, it is potassium. My non-metal with an IDE is sulfide. And then last but not least, we check if potassium is a transition metal. As I said, it's in group 1. The transition metals are 3 through 12, so the answer is no, which means we do not need a Roman numeral. Moving on to the next one, 2 is H2SO3. Obviously, we have H, S, and O, so that's more than 2 elements. We want to ID the polyion, and most often, the polyion will be the non-metal part. So SO3 is my polyion. Then, I name my metal, and H in this case behaves like our metal, so it's hydrogen. Then we name the polyion, which is sulfite. The H is not a transition metal, so no Roman numerals. And then before we would move on, or at the very end of the test, I would always say, check to see if you've written hydrogen anything. And the answer to that question is yes, you've written hydrogen sulfite. That means you have to change this to its acid name. And if you remember, hydrogenites become OUS, acids, so this would become sulfurous acid. You can star that one because that would be an acid case where we have to go down to the bottom. Number 3, CO4, we're back to 2 elements. C is to the right of the staircase in group 14. O is in group 16, which means we have non-metal. And this says use prefixes. So if there's no subscript with C, that means the prefix is mono, and we never put mono on the first element. The prefix for 4 is tetra, and O is oxide. So carbon tetraoxide. Number 4, NaBrO3. we have more than 2 elements, so I find my polyion. Again, most often it's the non-metal portion, so BrO3. I name my metal. Na is sodium. I name my polyion. BrO3 is bromate. And then, is sodium a transition metal? It is in group 1, so the answer is no, we do not need a Roman numeral then. Moving on to 5. 5 says Fe2 parentheses CO3 3. If you take a look, 1, 2, 3 elements, which means there's a polyion. It's already ID'd because it's in parentheses, so we follow our polyion steps. Name the metal. Fe is iron. Name the polyion. CO3 is carbonate. And then check if it's a transition metal. Iron is in group 8, which is in groups 3 through 12. Is it one of our 3 exceptions? No, it's not silver, cadmium, or zinc, which means we need to figure out the Roman numeral. So the first thing we try is uncrossing the charges. And if we did that, that would put a 2 up here and a 3 up here. Then the question becomes, is CO3 supposed to have a charge of -2? And the answer is yes. If that is true, this would be correct, which means what got crossed up to iron is also correct, so iron would be a 3. Number 6, H3N, back to 2 elements. Right? Is it a metal, non-metal, or non-metal, non-metal? It's one from the left, one from the right. So I name the metal hydrogen. I name my non-metal with an IDE, which is nitride. Obviously no Roman numerals, hydrogen's in group 1. And then we always say, did we have hydrogen something written? And the answer is yes. This was a hydrogen ide, and hydrogen ides convert into hydroic acids. So this acid name is hydronitric acid. So you have to do a little bit of extra work for those acid ones. Number 7, Ca3PO4 parentheses 2. We have 3 elements, which means we're working in this column. ID the polyion. It's already taken care of. It's in parentheses. So I name my metal, which is calcium. I name my polyion, and PO4 is called phosphate. Is calcium a transition metal? It's in group 2, so the answer is no. So we don't need a Roman numeral. Right? And does it say hydrogen something? It does not, so we're good with calcium phosphate. Last but not least, NO3. NO3 only has 2 elements. Is it a metal, non-metal, or non-metal, non-metal? N and O both lie to the right of the staircase, which means it's a non-metal, non-metal. So we're supposed to use prefixes. So there's a 1 after N, which means it would be mono, but we don't put mono on the first element, so it's nitrogen. 3's prefix is tri, and O with an IDE is oxide. So nitrogen, tri, oxide. So that's what it looks like when you fold acids into the different types that we already know how to work with. You name them the way that we already knew how, and then if you see hydrogen something, we have to use the acid table to convert it into the name that we want. Let's take a look at some where we want to write the formula. So remember, when we're writing the formula, what we care about is the identity of the things that are in the names. Is there a polyion? Does it have prefixes? And if the answer to those questions is no, then it's a metal plus a non-metal, and we follow those steps. Notice, the polyion steps are indicated by 8s and ites, prefixes, mono, di, tri, tetra, and so on. And then lastly, if you see the word acid, you have to change it to the old name and then proceed as normal. So let's take a look at some of these. Like first one, silver nitrate. So I ID my components. First one I always look for is prefixes because they're the easiest to spot. I don't see any prefixes there, which means I then look for polyions. Do I see 8 or ite? And the answer is yes. Here is an 8. So according to this, I should write the metal with charge, the polyion with charge, and then cross and reduce. Silver's symbol is Ag. It's a transition metal, so it should have a Roman numeral with it, but it is an exception to that rule. The reason being is we don't need a Roman numeral because silver is always +1. Nitrate is a polyion. It is NO3 -1. And then we cross and reduce. The 1's come down, and you end up with AgNO3. And we never put parentheses around the polyion if there is a 1 outside. Number 2, copper 2 oxide. If I'm going to take a look at this, first thing, I look for prefixes. Do I see any? No. No dis, tris, tetras, or so on. Polyions, is there an 8 or ite? No, it's ide. There are 3 exceptions for polyions that end in ide. Cyanide, no. Hydroxide, no. Peroxide, no. That means we're working here in the green column, metal plus a non-metal. So we do symbols and charges, and we cross and reduce. Copper's symbol is Cu. The Roman numeral tells us it has a charge of +2. Oxide is oxygen. It's in group 16. It's a -2. Cross those down, you get Cu2O2. And then these 2's will reduce. So copper 2 oxide's formula is CuO. Number 3. Right? 3 is hydrobromic acid. Right? And hydrobromic acid, right, is obviously an acid, so we need to get it to its old-fashioned name. Right? So if we're going to get it to its old-fashioned name, we have to figure out what type it is. And it looks like it's a hydroic acid. And hydroic acids used to be called hydrogen something ides. So hydrobromic acid used to be called hydrogen bromide. From there, it's very straightforward. Right? You're looking at a metal plus a non-metal, so it's symbols and charges, cross and reduce. Hydrogen is H+1, bromide, Br -1. Cross those down, and you get HBr. Number 4, pentacarbon noniodide. First thing I look for is prefixes. Do I see any? You bet. Penta, nona. So according to this, place the number of the prefix after the symbol in the formula. So pentacarbon means I have 5 carbons. Noniodide means I have 9 iodides. There's no crossing. There's nothing like that. Right? There's no reducing. You just write what you see. Jumping back up here, right, number 5, silicon dioxide. First thing I look for is prefixes. Like, do I see a prefix? Yes, I do. Like dioxide, prefix on oxide. Right, so according to this, you place the number of the prefix after the symbol in the formula. Sorry about that. All right, silicon dioxide has a prefix. All right, so place the number of the prefix after the symbol. No prefix on silicon, so just Si. Dioxide means 2 O's. No crossing, no reducing. We are good. All right, 6 says calcium nitride. First thing I check for is prefixes. Do I see any? I do not. Then I check for polyions. It doesn't end in 8 or ite. If it's not cyanide, hydroxide, or peroxide, it's not. That means we're going to be here. Symbols and charges, cross and reduce. Calcium is in group 2, so it's Ca+2. Nitride is N. It's in group 15, which makes it a -3. Cross those down, you get Ca3N2. Number 7, nitric acid. Right? Nitric acid is obviously not having prefixes. It's an acid, so according to this, use the table to get the old name. Figure out the type of acid. It's an ic acid. Ic acids used to be called hydrogen something eighths. So this used to be hydrogen nitrate. And from there it's normal. You do symbols and charges and cross it. H plus 1, NO3 minus 1, cross and reduce, and you get HNO3. Last but not least, potassium dichromate. I chose this one special because of how it looks. First thing we check for is prefixes, and I would think, yes, I have a prefix. There's a di there. Right? But then, as I went to try to write this, I would notice, right, potassium isn't a nonmetal, which doesn't make sense. There's no prefix, which would be okay. Right? But then, you'll never find the word chromate on the periodic table. Right? It's because it's a polyion, and I wanted to highlight dichromate as not an exception, but you just have to be aware that dichromate is a polyion. It's not a prefix in front of chromate. All right, so that means this is a polyion version, so we have to do symbols and charges and cross. Potassium is K plus 1. Dichromate is Cr2O7 minus 2. If you cross and reduce, you get K2Cr2O7, right? Because the 2 and the 1 outside the parentheses that got erased would not reduce. So I hope this helped keeping things straight and in order with naming things and writing formulas whenever they are all mixed up together. Remember, you're not going to have any of these devices on your quizzes or tests, so try to get this pattern locked into your brain so that it's secondhand nature when you go to show me what you know on your quizzes and exams. As always, if you're having any other questions or difficulties, please come in for some help.